Very good afternoon to all. I am Dr. P. Usharani, Professor EEE Department, RMD Engineering College. I am going to present a topic on various power operating states, or the other name as state transition diagram in power systems. In power system, there are 5 operating states. First one is normal state or secured state. Second one, alert state. Third one, emergency state. Fourth one, extremist state. Fifth one, restorative state. We'll see one by one. The state transition diagram shows all the 5 states. Okay. First one, normal state. If you take care of normal state, the normal state means there are 2 constraints we are considering here. One is equality constraint. Generally, equality constraint as your sum of generation must be satisfying your demand. Power balance equation. Okay. First constraint we are considering equality constraint. Second constraint we are considering inequality constraint. Here inequality constraint we can say generation limits, bus voltage limits, equipment currents, everything else within the limits. Okay. So there will be given minimum and maximum. So whatever the values, which should be within that limits. So we are considering here equality constraint and inequality constraint. Okay. So if the system is said to be normal means, okay, normal means both load as well as operating constraints are satisfied. Here if you take care, we can say the other name for that as normal state. Normal state means all the postulated contingencies, whatever we are taken care, are within the normal range. Okay. That means any equipments in the system, whatever we are considering, is not overloaded. Okay. All the systems, all the components are within the normal range. That's the meaning. So here, if we are saying normal or secured state means equality constraint as well as inequality constraints are satisfied. Okay. If you are saying a normal state to be insecure means, okay, that means the system may be violated. Okay, that means some constraints in the system may be violated. So if the system we are saying which is insecure means the frequency you should consider as well as the bus voltage magnitude, everything we have to take care, and the current flows. Then transformer, generators are operated with the given specified ratings. Load scheduling, everything we should take care. So normal means it satisfies your both the constraint, equality constraint as well as inequality constraint. In the case of second type as alert. Alert as if any fault occurs, okay, any fault occurs, your system goes to alert state. That means the constraint limits is violated. So if the security level of the system falls below certain level, okay, or the probability of disturbance occurrence will be increases means the system we are saying alert state. Okay. So that is insecure state. Insecure state, even though all the equalities and inequality constraint, that is your power balance as well as the limits of voltage generation limit as well as the current limit are satisfied. If the disturbance occurs, it may directly move on to emergency state. To bring back the system from emergency to alert state, we are using preventive control action. Okay, preventive control action to restore the generation or the disturbance of the system. You are bring back to the system to the normal state. So we should take care the preventive action as economically as possible, such that the system, that is the quality of the power supply, is maintained. Quality here as we are considering power quality means the voltage waveform shape. Okay, whatever the consumer end we are going to deliver, that must be in a proper power quality, means reliable quality power must be supplied at our end. So from alert state, if fault is severe means it may directly move on to extremist state also. Okay, that means the fault is severe. So this is your alert state. Third one, emergency state. If any severe disturbance occurs, okay, severe disturbance occurs, the system, the power system enters to the emergency state. So this emergency can directly from normal state it may comes, or from the alert state we can it may come directly from normal as well as alert state. So here the operating constraints are violated. Even though the operating constraints are violated, the load constraint are satisfied. That is, the equality constraint as in change. Equality constraint as such it may be there. Okay, only the inequality constraint may change. So here the system may be restored to normal or alert state, okay, by means of the preventive control action. So you should take some action, that we are saying preventive control action, that is we should do disconnection of faulted sections or the load shedding. Okay, so you are bring back the system by using the control action, that is emergency state. Next one is extremist state. Here the emergency control actions fails when the system is in emergency state, that is it may move on to extremist state. Okay, that is there is no preventive control action taken in the proper time means. Okay, in the any severe disturbance, if you are not taking any preventive control action, it may directly move on to extremist state. So that means both, that is neither the load nor the operating constraints are satisfied. So that means it must be islanding that we are saying islanding state. Okay, the generation limits beyond their capacity, so you should avoid that one. Okay, you should bring back the system immediately to normal or emergency state. So we are using uh, that is we are bring back the system from the islanding condition to uh, emergency or normal state. That means the generation will be satisfying the demand. Okay, if the components are overloaded means the active power balance is disturbed, so you should strip the proper generation, that means load shedding properly. Even it may occur blackout. Blackout means fully shut down. Okay, so you should take proper control actions, that is load shedding, and the control systems we should use. It may take a few minutes or few hours also. Okay, in some cases to come to normal state or the emergency state. Okay, that is extremist. Next one, we are going for restorative state. In restorative state, the system must bring back to either to alert state or normal state. Okay, which is a slow process. Okay, which is slow process. So bring back the system from normal to restorative or the alert state, we are using some control actions. We can switch off the loads. So afterwards, we can pick up gradually, and we should take care of the synchronization of the operating islands. So the control actions from the central energy control center we are taking. So till now we have seen the 5 operating states. Okay, normal or secured. Second one alert. Third one emergency. Fourth one extremist. Fifth one restorative. These are the 5 operating states in power system operation. Thank you.